Hello and welcome to the Geotechnical Engineering Podcast. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Alp Gökalp, who is the Deputy General Manager of Kasktas Co Incorporated in Istanbul, a leading specialty geotechnical contractor in Turkey. We'll be talking about geotechnical applications and mega infrastructure projects in Turkey, and also about his involvement in the Eurasia Tunnel Project, an underwater tunnel between Asia and Europe. I'm your host, Jared Green, and this is the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. Before we get started here, this is a free show, and our sponsors help us to keep it free. And now I'd like to recognize our sponsor for today, that being Menard USA. Menard USA is a specialty ground improvement contractor that works nationally, providing design-build ground improvement solutions at sites of problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard Group USA or for help on your next project, please visit www.menardgroupusa.com. That's www.menardgroupusa.com. And with that, let's jump right into today's episode. Hello, and welcome to another episode of the Geotechnical Engineering Podcast. Alp, how are you?
Thank you very much, Jared. I'm very well indeed.
Excellent.
And I would like to thank you for inviting me. It's really great to be here with you.
Okay, great. Well, I appreciate you spending some time with us all the way from Turkey.
Yeah, correct.
Excellent. Well, in your own words, can you tell us a little bit more about yourself? Tell us a little bit more about your education and why and how did you become a geotechnical engineer?
Okay. My name is Alp Gökalp. I am the Deputy General Manager of Kasktas Istanbul, Turkey, a leading specialized geotechnical contractor. I was graduated and got my BS degree in civil engineering from Istanbul Technical University in 1990. I got my master's degree in geotechnical engineering from Middle East Technical University in 1994, where I worked as a research assistant for 3 years. Since my graduation, I have been working as a geotechnical engineer. And during this period, I worked at different positions and in different countries. I worked as site engineer, site manager, project manager, technical office engineer, technical office manager, contracts manager, and finally, deputy general manager since 2017. I'm married with one child named Demir. In English, it's Steel. I'm a member of TC 209 Offshore Geotechnics and TC 307 Sustainability in Geotechnics Technical Committees of ISSMGE, International Society for Soil Mechanics and Geotechnical Engineering. Last month, in June, I was elected as the board member of Turkish Committee of ISSMGE. How I became a geotechnical engineer? Actually, it is very easy to answer and it's very short. When I was a third-year junior student at Istanbul Technical University, my supervisor, who is a professor at the geotechnical department, has not only convinced me to become a geotechnical engineer, but he also makes me understand and enjoy the field of geotechnical engineering.
That's awesome. That's awesome. And now I understand you're the Deputy General Manager at Kasktas?
Correct. Yes.
Okay. Can you tell us a little bit more about the history of the company and maybe the structure of the company as well? And I understand you worked in many countries. Talk about a little bit more about the countries you work in as well. I think that's pretty interesting for our listeners.
Okay. I have been working at Kasktas for 26 years, since 1995.
It's a long time.
Yeah, for a long time. Actually, it is a pleasure. Kasktas established in 1957 as the piling group of ENHANCEMENT Construction. Then in 1975, Kasktas, a separate company, was founded. Our mother company, ENHANCEMENT Construction, is the leading Turkish contracting company in Turkey. ENHANCEMENT has completed approximately 550 projects in 46 countries with a historical contract value of $51 billion. So it is one of the leading company. Kasktas, on the other hand, has completed its initial contracts in Saudi Arabia, Gulf countries, and Russia in the beginning of 1980s. Since the beginning of the year 2000, Kasktas has further expanded projects into a total of 21 different countries, among them Nepal, Afghanistan, Papua New Guinea, Bahamas, Gabon, Djibouti, and so many other countries in Europe, post-Soviet states, and Gulf countries. Today, Kasktas has a branch office in Moscow, Russia, and a subsidiary in Saudi Arabia named Kasktas Arabia, with an office in Jeddah.
Cover a lot of ground. You cover a lot of ground. And
Yeah.
what size elements are you installing? Roughly,
Well,
like from a diameter standpoint.
Diameter standpoint, 150 centimeter to 200 centimeter board piles. As for the barrette piles, I think the maximum depth is 100 meter, 99.5 meter deep barrette piles we have installed 2 years ago in Izmir. It is the longest barrette pile. Wow. And as for the board piles, 150 centimeter with a length of 76 meters.
Okay, got it. And are you all doing the design, or is the design done by somebody else and you're focusing in on the installation only?
Yeah, to be frank with you, we have a very powerful technical office. We usually make our designs, engineering and construction all together. But sometimes the contractor or the client has their own design, so we just only change the design and make it constructible. Or we are preparing shop drawings for construction.
Got it. Awesome. And what would you say is your most challenging project that you've worked on in Turkey that you completed? And talking about those challenges, how did you overcome any difficulties regarding the installation, or maybe even as it relates to shoring, excavation shoring?
Well, Jared, it is really very easy because the most challenging and most difficult project we have completed in Turkey is Osman Gazi Bridge project, because it is exactly located in the highly seismic area, which is one of the highest in all around the world, actually. Actually, within the content of this project, we have completed 4 different subcontracts, but among them, 2 structures are very critical, namely South Anchor Block and South Approach Viaducts, in which special and state-of-the-art geotechnical applications are implemented for the first time in Turkey. You should know that these special applications are also very limited around the world. Let me give you some more information.
Sure.
First of all, the bridge is very interesting and very unique. The 2,682 meter long Osman Gazi Bridge with the 1,550 meter main span is the longest suspension bridge in Turkey and the 6th longest central span bridge in the world, which is located at one of the most seismically active places in the world, as I mentioned before. Just a few days ago, the 5th year anniversary of the bridge has celebrated. As you know, Jared, in general, when designing structures in seismically active areas, foundations of critical structures are typically located away from the known fault line. However, for long structures such as bridges, tunnels, and pipelines, a fault may be unavoidable and fault rupture risk impossible to preclude. Unfortunately, Osman Gazi Bridge project area, both South Anchor Block and South Approach Viaducts, are exactly located on the secondary fault zone of the North Anatolian fault line. Moreover, they are also seated on deep alluvial deposits of soft soils that are unstable and liquefiable. Therefore, to overcome all these potential problems, a unique and innovative solution and design are applied for the shoring system of the South Anchor Block and the foundation system of the South Approach Viaducts. The first multi-cell cantilever diaphragm wall application in Turkey was designed and constructed for the shoring system of the South Anchor Block. A cantilever diaphragm wall by hydraulic cutter method, which is 100 centimeter thick and 33.5 meter deep, a rectangular plus two multi-cell having a very artistic shape, guitar shape layout was chosen as the most suitable and economical shoring system by Cove from Denmark, who is the designer of the bridge. As far as I know, this is the first and only guitar-shaped deep shoring structure within a reclamation area in the world. Likewise, another state-of-the-art application, the first continuous horizontal reinforced diaphragm wall application in Turkey was designed by Viacon from Taiwan for the box-type foundation system of the South Approach viaducts. South Approach viaducts is composed of 11 piers constructed along a 1,400 meter line with approximately 125 meter intervals. Okay. Both construction works were successfully carried out in accordance to the strict HSC, quality control and quality assurance programs implemented in the project. These works are considered as a good model in Turkey, which verifies that major iconic structures can be constructed at one of the most seismically active places in the world. Osman Gazi Bridge was officially opened to traffic on 1st July of 2016.
That's awesome. That's awesome. And when you say guitar shape, I mean, what governed that shape? Was it the extent of the foundation, or was there a geometric advantage of having that type of shape? I mean, what drove that? It's pretty unique.
Yeah, as you know, Jared, the anchor block of a bridge actually should have enough concrete volume, and the designer prepare actually a concrete volume, but having a deep excavation of 16 to 17 meter deep in a reclamation area. When he makes a rectangular shape, we need to install very long anchors to laterally support the excavation pit. And in this case, the project will be longer and much more expensive. But with the help of the circular shape, they actually use the circular shape so that there are no lateral struts or anchors.
Okay.
And finally, the total volume becomes the shape of the anchor block of the bridge.
Okay. Got it. And is there like an internal ring beam or something like that as well to provide some lateral stability?
No, there are no inner beams, but there are two important reaction blocks. Reaction blocks are very critical to support and to transfer the very eccentric and heavy loads. The problem is we have installed, as far as I remember, around 120 numbers of diaphragm wall panels.
Okay.
But the problem is it must be 100% accuracy with an accuracy of 1/200 and sometimes 1/400 alignment.
Wow.
Otherwise, the system cannot be used, cannot be applicable.
Wow.
Because all the structure is working as a pressure, under the pressure. So each and every panel within the circular area supports each other and transfers all the eccentric load to the reaction block. Only in the central reaction block there are some reinforced concrete struts and supporting piles.
Okay.
Well, but as I mentioned, actually, it is one and only. Actually, it is a unique project. I really search for Google. I really search for different projects. I try to understand if there is another guitar shape, but I couldn't find. Actually, there are two cells or three multi-cells, but no guitar shape, frankly.
That's great. And I understand you've also been involved in the Eurasia Tunnel Project, which is, I understand it's an underwater tunnel from Europe to Asia. Could you tell us a little bit more about the project and your involvement on the project?
Of course, with pleasure. We have involved in the Eurasia Tunnel Project as well. The Eurasia Tunnel Project, actually a century-long dream project, let's say, and having a 1.1 billion US dollar investment project, connects Asian and European sides of Istanbul by a highway tunnel passing underneath the seabed with a specially designed TBM, tunnel boring machine. The Eurasia Tunnel is also a special tunnel. It is the sixth place in the world with its 13.7 meter excavation diameter at a maximum depth of 106 meter below sea level.
Wow.
Which allows, which allows an inner diameter of 12 meter with 60 centimeter thick lining. And it is in the second place in the world with high hydrostatic pressure, which means 11 bars resulting from 106 meter depth below the sea level. So from these two aspects, actually, this tunnel is actually very special tunnel. And crossing the Bosphorus, it is 3.4 kilometer long. And there are some other sections constructed by new Ausurian tunneling method and some part cut and cover. And as a total, actually, it is 14.6 kilometers. The tunnel, unfortunately, passes through very complex geological structures, transition zones, and marine sediments in, again, very highly seismic area. It is just 17 kilometers away from the North Anatolian fault line. To decrease the seismic stresses and strains below the permissible levels, two flexible seismic joints and segments were designed and applied in the tunnel. A joint venture, YMSK in Turkish, consisting of Yapı Merkezi from Turkey and SK from Korea, has undertaken the construction of the Eurasia Tunnel. Kasktas, we have worked as the specialist geotechnical engineering subcontractor for the execution of the shoring works at two critical structures, Asian transition box and European transition box of the Eurasia Tunnel Project. Eurasia Tunnel was officially opened to traffic on 22nd December of 2016.
Very nice, very nice. So that sounds complicated.
Yeah, it's very complicated, and when you go into detail, all the designers, actually, I just give you very limited information, but it's all around the world. There are Germans, there are British, Americans, so there are very different companies get involved in this project.
Excellent, excellent. And with all those challenges, I mean, have you ever have you ever seen some of those things in other places, or was it just a lot of first? You know, it's like, what are we gonna do here? It's like, oh, it's the first time we're doing this. The first time we're going this far. You know?
Yeah, yes. Frankly speaking, in the last 5 years, all investment projects in Turkey are actually very challenging projects, and we are get used to do the pioneering projects, doing the first projects. So we are get used to it actually.
So we're running out of. I've often heard it said there are no more easy sites. You know.
Yeah, in all my 26 years experience, there are no easy jobs, but especially in the last 5 years, they are all challenging projects, the most difficult projects.
Mm-hmm. And as geotechnical engineers, I mean, we go into this because we like the challenge, right? You know?
Yes, exactly. I'm very happy.
Excellent, excellent. So from a geotechnical standpoint, you know, what are some of the challenges that you see when you work on infrastructure projects? Because you've worked on a lot of infrastructure projects recently, but what are some of the challenges you're seeing related to infrastructure projects?
Well, from a geotechnical engineering point of view, we have executed shoring structures at the tunnel project. One of them is Asian transition box, which is the launch shaft of TBM in Haydarpaşa at the Asian side of the Istanbul. Whereas European transition box, which is for receiving shaft of TBM in Çatladı Kapı at the European side of Istanbul. Let me give you brief information about the geotechnical point of view for the Eurasia Tunnel Project, because
Sure.
both transition boxes are very important because they are the receiving and launching shafts. So the most critical milestone projects. Asian transition box has a rectangular shape with a dimension of 170 meter by 25 meter. And it is maximum excavation depth was 39 meter. A two-stage shoring system consisting of board piles supporting with pre-stress anchors are selected by the designer Parsons Brick and Horf. At the European transition box, again it is a rectangular shape with a dimension of 70 meter by 30 meter, a substation building and a 600 meter long access road, cut and cover section I mean, are also located in the same area. The maximum excavation depth is in this area was 31 meter. All these deep excavations, Jared, were executed just 10 to 15 meter away from the Marmara Sea. So they are very close to the sea. It's in the proximity of the shoreline. A shoring system of diaphragm wall, again by hydraulic cutter method, was selected by the designer Su Yapı Mühendislik from Turkey. There are steel and reinforced concrete struts to resist lateral forces. And there is this part is very critical because in order to improve the weak ground and to resist high groundwater pressure during receiving of TBM, a 30 meter deep impervious block was required in order to create a transition zone composed of 120 centimeter diameter unreinforced second board piles. Exactly, they were constructed along the TBM axis of the receiving area. Moreover, in order to increase the stability of the shoring system against the high lateral pressures, a grid of underground support system composed of unreinforced diaphragm walls with a thickness of 100 centimeters were successfully constructed. In this project, deep excavations up to 39 meters along the shoreline of Marmara Sea have been completed successfully and right on time. And actually this concrete block, this impervious block was very critical because, as you remember, the TBM machine was working 106 meters below the sea level, so that actually TBM itself carries 11 bars. Once it is open to the open automatic, the atmospheric pressure, there is a difference of 11 bars. In order to reduce this high water pressure, there must be a transition zone which was composed of second board piles, unreinforced second board piles. So these details seem very easy for you, but frankly speaking, if there will be one mistake, there will be huge disaster or there will be a huge impact on the schedule of these very important prestigious projects.
Got it. And I'm sure that you had milestone dates that you had to hit, right? I mean, you have to have this much done by XYZ date. So those things are critical. They're critical.
Yeah, Jared, these structures are critical. And what we are doing as a geotechnical engineer, maybe it seems easy job, but if we do not done this job properly, the whole project will be on hold or the whole project will be postponed. So there will be some incredible delays. So as a geotechnical engineer and as a geotechnical applications, we are always on the limit. We are always forcing the project done as soon as possible. So we have to complete on time.
Excellent. So you have pressure. People are applying pressure, definitely.
Yes.
I'd be curious, when you're managing all these type of challenging projects, especially around the same time, are there any special management tools or software or innovative approaches that you're proposing or applying that are helping you be successful?
Well, yeah, first of all, actually, it is really a privilege for me and our company that we have a chance to get involved in major infrastructures in Turkey, such as Osman Gazi Bridge, Eurasia Tunnel, Star Refinery, Akkuyu Nuclear Power Project. It's an ongoing project, and 1915 Çanakkale Bridge project along the Dardanelles Strait. Jared, please note that once Çanakkale Bridge is completed, it will be the longest central span bridge in the world. Wow. With a 2,023 meter central span length. Osman Gazi Bridge was 1,550 meters, and it is in the sixth in the world. Now the record will be Çanakkale Bridge with a 2,023 meter central span, and which represents the 100th year anniversary of the formation of the Republic of Turkey, which is 1923.
That's awesome. That's awesome.
Yeah, actually, we have managed and completed these prestigious projects, maybe because of the following reasons: skilled technical and managerial staff, a powerful technical office, a fully owned machinery equipment fleet. Besides, as you asked, we have using an innovative cloud-based software programs for actually every aspect of the construction work, such as procurement, HR, machinery equipment management, finance, document control, HSE applications. So these new cloud-based software are implemented by our sister company named ENHANCEMENT for the last 5 to 10 years. And the last one, I guess, is the implementation of the Building Information Modeling, BIM-based geotechnical engineering designs.
Okay. Excellent. Excellent. Well, a lot to unpack there and a lot to learn. I know from our, we have a lot of younger listeners that are working on, one project. They're working on a subsurface exploration, they're drilling borings and, pushing cones, excavating test pits. And it's hard to kind of get your head around the scale of what you're talking about. But I think it's, one project at a time. And as you gain experience, you use that for your next. But I'd be curious to hear some of the advice that you have for our younger listeners, younger engineers, younger geotechnical engineering students, and perhaps even those that are thinking of being a civil engineer and they're toying around with going in the geotechnical. Any advice that you can give them before we take a break here?
Of course. As I mentioned, Jared, I have been a geotechnical engineer for almost 30 years. I'd like to share some of my experiences to civil engineering students.
Yes,
my advice to young engineers would be to work in a field which they like and enjoy. This may sound you very simple and easy, but I believe this is one of the key factors for success. To be frank with you, as a civil engineer, we are very lucky that there are different areas of work in civil engineering. If young engineers or students can choose a field of work which they like to study and to work, then I believe they will have a big chance to be successful in their professional life. From my understanding and from my experience as well, geotechnical engineering is a kind of art. Let's say art of engineering. I'm a geotechnical engineer. Each and every site is unique and a new case study for me. I myself and my team have been learning a lot from each and every new project and new site. Besides, in geotechnical engineering, a lifelong education and learning is required and essential. Therefore, if a young engineer is curious, likes research, innovative techniques, high-tech machinery equipment, then geotechnical engineering is the right answer and correct field of work, I believe.
Excellent. I like that. Right answer. Right answer. So with that, we're going to come back in just a minute. We're going to close this one out in Alp and our career factor safety end segment. Stick around. All right, welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate what we want to say a factor of safety into your design. But what about incorporating a factor of safety into your career? So today, of course, we're speaking with Alp Gökalp. Alp, you've already had a very successful career, but as you look back in your career, what's something that you've implemented in your career to give yourself a factor of safety in your career?
Okay. Looking back to my career, if you don't mind, I would like to give you not one, but two things that I implemented into my career to
Excellent.
give myself a factor of safety.
Okay.
First one is doing master's degree in geotechnical engineering and being a research assistant, so that I have learned how to make a proper scientific research, literature survey, reading papers, preparation and writing technical reports, papers, and presentations. Then during my whole professional life, even as of today, because I have a full paper submission tomorrow, I have continued my academic studies, no matter how difficult it has been. I have authored and co-authored over 50 papers published in national and international conference proceedings. I have attended local and international conferences organized by ISSMG, ASCE, DFI, and Turkish Local Committee of ISSMG, including European Conference, World Conference. So I am a professional, but I have always within the academic events. All these highly sophisticated and very disciplined technical studies enlighten my whole professional life and engineering career. I also believe that it opens a door to top management level as well. The second one is marrying with my wife, Feride, like Frida, who is also a civil engineer with a master's degree in geotechnical engineering.
Wow, two geotechs.
Yeah, and but she's even better because she has also an executive MBA degree. So that I have a chance to discuss and talk with her about every aspect of construction, engineering, project management, contracts, claim management issues, which gives me an additional confidence and support whenever I need.
That's awesome. I love it. I love it. Well, thank you so much for coming on, and thank you for sharing all the great insights with us. You shared some great information and advice that I know is going to be helpful for our listeners. And if a listener is, listening in or viewing, I should say, where can they find you? If, are you on social media or an email you want to share with us?
LinkedIn, they can find me with my name and surname, Alp Gökalp, in LinkedIn. Actually, it is the easiest way to find me. And our company has a website, kasktas.com.tr. So through these two facilities, they can reach me.
Excellent. Well, thank you so much for coming on. This is great.
Yeah, thank you, Jared. Thank you. You are very kind. Thank you.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 30, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.